Now it is started recording. Okay. Good afternoon, class. Okay. As you already know that I'm going to deal the subject system design through Verilog. And now we will I'll share my screen and we'll have discussion with the help of PPT. Okay. Now I'm going to share the screen. So are you able to see the CS has to give the answer? Are you able to see the
Yes, sir.
screen?
It's visible, sir. Visible, sir.
So now you can see that now we are in academic year 2021 and you are 4 by 4 B section and it is semester 1. The subject what we are going to discuss is system design through Verilog and simply we are calling it as Sdtv. It's an elective one. It is an elective one for you. Next, so if you go through the syllabus once, we have Verilog as HDL. So in the are you able to see these slides? I share the screen also. Are you able to see
Yes,
the
sir.
slides? Okay.
Yes, sir. It's visible, sir.
Okay. Okay. You see the introduction. First unit is regarding the introduction to the Verilog. So in the previous classes, that means in the third year, we have seen the VHDL, and that means before second in the second year or third year, you have seen the VHDL, right? Isn't it? Okay. We have seen this VHDL. That is also one type of hardware description language. This is another type of hardware description language. This is Verilog hardware description language. So in the syllabus first part, that unit 1 is dealing with the introduction to the Verilog, where you can see Verilog as an HDL, and we have different levels of design, description, concurrency, synthesis, simulation and synthesis, and functional verification and system tasks, programming languages interface and module simulation and synthesis tools, test benches, and also we have some language constructs and conventions. Okay, this is the part B of first unit itself, language constructs and conventions. Okay, next in the unit 2, we'll be discussing regarding the gate level modeling, and we'll see first the introduction to that, and ungate primitives, some ungate primitives, module structures, and other gate primitives. And we'll have some examples. We'll discuss some examples there, and we can also see some tri-state gates there. We can also see some tri-state gates, and we can also have some array of instances of primitives and design of flip-flops with gate primitives, and some delays, strengths and connection resolution, net types, design of basic circuits in the second unit itself. And in the third unit, we'll be discussing regarding the behavioral modeling, what the behavioral modeling is. And if you recall the concepts of VHDL, very high speed integrated circuits, hardware description language, there based on the architecture, we have four modeling styles, right? Do you remember this? One is data flow model, other one is behavioral model, and the fourth one, sorry, third one is structural model, and the fourth one is the hybrid model, where the hybrid model is the combination of any of the two or the three. Okay. Then here in a similar fashion, we also have in the Verilog also. In the Verilog also we have these concepts. Okay, such as the behavioral modeling. In each of the units, we will be discussing one modeling style. Behavioral modeling, you can see here some operations and assignments and some functional bifurcations, initial constructs, always. We have some statements such as always, and we can have some examples also on those assignments with the delays. That means assigning the delay to the signals. Some wait statements. Here, construct in the sense the syntax. Construct in the sense here syntax, and we can also have multiple always blocks also. Okay, we can also have multiple always blocks also, and we can have simulation flow, if and if else constructs, and we can have assign and deassign constructs, repeat constructs for the loop. Okay, and how to disable the construct also we also have while loop, forever loop, parallel blocks, force release and construct, force release construct, and events. We have different types of events also there. And in the fourth unit, we'll be receiving the data flow level and the switch level modeling. Okay, these are the different types of modeling styles in Verilog HDL, right? And now in the fourth unit, you are going to see data flow level and switch level modelings. So in that, you will be seeing the introduction, continuous assignment structures, delays, and continuous continuous assignment to vectors, basic transistor switches, CMOS switch, bidirectional gates, and time delay with switch primitives. Instantation with strength and delays, strength contents with tri-register nets. Also, we can see there in the fourth unit itself. In the fifth unit, we'll be going for synthesis of combination and sequential logic circuits using Verilog. You can classify the circuits into two categories, right? Okay, What are those? Generally, they are classified as sequential circuits, and other one is the combinational circuits. So those things we can design, and we'll be learning the syntaxes, and we'll be writing some programs there in the fifth unit for some sequential logic circuits and some combinational logic circuits. Okay. Okay. Okay, and we can go with the different types of Verilog models. That means, as an example, we can design some static RAM memory and a simplified 486 bus model and interfacing memory to a microprocessor bus and UART bus, sorry, UART design and design of microcontrollers CPUs, microcontroller CPUs. That means from the scratch onwards, we are learning Verilog HDL from the scratch onwards, from minimum level constructs to the designing of a very big, designing of small devices, right? So we have some textbooks. As these are the four textbooks. These are the four textbooks in our syllabus, prescribed syllabus. Okay. Textbooks such as Design through Verilog HDL. This is the first textbook which I have sent to you, uh, previously. Digital, sorry, Design through Verilog HDL by T.R. Padmanabhan and B. Bala Tripurasundari. And we have one more textbook called Advanced Digital Design with Verilog HDL. And we have two reference textbooks. One is Fundamental of Logic Design with Verilog, um, and another one is a Verilog HDL primer. Actually, it is a Verilog HDL primer by J. Bhaskar. Okay. Not only these four, we can also have one more textbook called as a Verilog HDL by Samir Palnitkar, which is also a good textbook, and to know the basics, and also which will be very much helpful while you write programs in Verilog HDL also. Okay. Now we'll see the main objectives. When before going to the discussion of the test subject, we can we first have to see the what are the objectives of this subject or the course we call, and we also have some outcomes after learn. What are the outcomes? Outcomes means after successful completion of the subject, what the student might have learned. So first we'll have generally we'll have the objectives, and at the end we'll be seeing the course outcomes. Here the main objective of the subject is what is that? Main objective of the subject is to make the students learn and understand the basic knowledge of Verilog HDL. Okay, basic knowledge of Verilog HDL, and also the student must learn and understand the language constructs and conventions in Verilog HDL. Different types of constructs, such as we can say some always statement, or else some always statement, or any other different types of syntaxes. And student must also should learn and should understand the basic concepts of Verilog HDL, like data types, system tasks, and compare directives also. These are the objectives. That means to these are the objectives of the subject. Okay. After the completion of the subject, we will be having some course outcomes. Okay, that is verifying whether you have learned or these course outcomes or not. That means whether you have gone with this or not. You have to understand whether you have understood the Verilog hardware description language and synthesis of digital circuits using various models, or are you able to implement digital circuits utilizing various constructs and convention of Verilog in different models, and also to differentiate various Verilog models. As we said, we have different types of modeling styles in the Verilog also. You must be able to differentiate all those, and you must be able to write the programs in those formats. Okay, these are the objectives and outcomes. Now, if you just go with the general introduction of the subject related ones, that is, what is an hardware description language? You all know that hardware description language is writing some code, hardware description language code, and verifying the functionality of the devices. Right? And if you go through that, so hardware description language, you see there, it describes the structure and behavior of electronic circuits and most commonly the digital logic circuits. Okay, and it is used to program electronic and digital logic circuits. And generally, for an example of hardware description languages, we commonly used to say VHDL, that means very high speed integrated circuits hardware description language, and Verilog HDL, and System C is also one among the commonly named hardware description languages. Okay. Next, you see with the subject related introduction. So as you have seen this, the digital, the word digital has made a dramatic impact on our society, isn't it? Yes, the word digital has made a dramatic impact in our society. We are using different types of ICs when there is some digital display, or else any, if you see any of the gadgets which are a digital one, definitely there will be one integrated circuit mostly. Okay, so this digital concept has a very good impact in our society, and also we are finding solutions to many of those problems. Most of the problems are being solved with the help of digital circuits. So if you go through that, starting from electronic instrumentation onwards, and controlling of the devices and data manipulation, signals processing and telecommunications, and up to the consumer electronics. Okay, first let me say what is this. We are going for electronic instrumentation. So that means we have different types of instruments in heavy industries. Okay, and now at present they are also being controlled with the help of electronic chips or electronic gadgets only. The operation of the heavy machinery is also being controlled by the simple digital circuits. It is also being, it is also controlled. It is also controlling. The digital circuit is also controlling, and we have different data manipulations and signal processing. Signal processing, that means you have seen the signals and systems. Oh, meeting will end within 10 minutes. Okay, from electron signal processing, telecommunications to the consumer electronics. Even the general consumer electronics such as washing machines or any other consumer electronics also, we are having nowadays digital displays and automatic controls. All these things are possible with the help of digital circuits only, or digital designs, or digital systems only. Okay, so development of such solution has been possible due to the good digital system design and good modeling techniques. Okay, you can. So, so first one is the conventional approach to the digital design. What is the conventional approach to the digital design? Okay. For example, if you see, do you remember the small scale integration, medium scale integration, large scale integration, and very large scale integration, and ultra large scale integration? That means ULSI. These are the generations of integrated circuits, right? You see, digital ICs of SSI and MSI, that means small scale integration, medium scale integration, has become universally standardized and have been accepted for use. Okay, for an example, if you see here, I am taking a simple function, releasing a function such as qn plus 1 is equal to qn plus a into b. Qn plus 1 is equal to qn plus a into b. Here, qn, a and b are the Boolean variables. And what is qn? Qn is the nth time step of q. Nth time step of q, and a and b. If you see here, qn plus 1 is equal to qn plus a dot b. Dot indicates the AND operation, and plus indicates the OR operation. Here you are simply using an AND gate and one OR gate, right? So simply using one AND gate and one OR gate. Okay. So see here, you are, for the same equation, you can write the circuit, or you can draw the circuit like this. You can see A and B is combined, is given as an input to the AND gate, and getting a result from A and B AND gate, and it is fed as an input. It is fed as an input. The output from the AND gate is fed as an input to the OR gate, and the output from the OR gate is once again given to the flip flop, some basic flip flops. Generally, we used to take help of AOI and or inputs, and OAI or and inputs. These type of gates and also some basic flip-flops for performing the operations. See, if you see, so in the conventional approach of digital design, we we generally used to design a large circuit. If it is necessary for us to design a large circuit, first what we think is, first we have to see what are the required components, basic required components. First we will see that. Later, if the basic components or the required components are not available with us, what we have to do? We have to design by our own those components. That thing what we have learned in the VLSI, the required circuits. What are the required circuits? What are the circuits is required? We will be designing in the VLSI. Before that, instead of designing the total circuit physically, to verify whether it is going to work properly or not, we have to go for the hardware description language verification, that is simulation and synthesis. For that purpose, we have different types of languages such as VHDL, Verilog HDL, System C, and generally in industries we used to call Verilog HDL as a golden language. Okay. Uh, so you see here with compared to large circuits, the task mostly reduces one of identifying set of ICs necessary for the job and interconnecting. First, we have to identify. That means first we should have an idea of what should be the inputs and what should be the output. To get those output, what are the components we require? We should have an idea. After that, to get those outputs, whether we have these components in our library or not, we have to see. If we don't have in our library, we have to design by our own. First most main task of designing a large circuit is identifying what are the ICs necessary and how to interconnect one IC with the other. And rarely does one have to resort to the micro level design. What does here micro level design mean? Micro level design is nothing but we have to design from the scratch level. What we have design from the scratch level or fabricate from the scratch level, such type of ICs. Okay. And we have some accepted approach to digital design. Okay, that thing we'll see in the next class. Just you revise once what we have discussed in today's class. So we have seen the syllabus content. We have seen the syllabus content and what are the reference textbooks and what are the main textbooks and what are the course objectives and what are the course outcomes. And also we have gone with the different general introductions for the hardware description languages. And we have seen commonly used and generally seen hardware description languages such as VHDL and Verilog HDL and System C. And generally for designing of digital circuits we'll be using these hardware description languages. You know, we have some advantage of learning the hardware description languages. You know that when an IC has to be fabricated, it consumes more amount of money. Instead of that, we will be verifying on the hardware description languages with the help